Greetings to Sir Dalman bin Peter, our design project reinforcement concrete and design lecturer.
Assalamualaikum and hi, my name is Nur Izzatul Afifi binti Ramli and my card matrix number is 07GKA18F 2014. Today, I will present about the elastic analysis beam. So, what exposed on this slide is the roof beam layout where the area we thought was A/1 until 3. A specification, there are 3 load cases will be considered. Among them are all span loading with maximum load 1.35 GK plus 1.5 QK. Second, span 1 loaded with maximum load 1.35 GK plus 1.5 QK, and span 2 loaded with minimum load 1.35 GK. And the third is span 1 loaded with minimum load is 1.35 GK, and span 2 loaded will be maximum load is 1.35 GK plus 1.5 QK. Next is loading on slab. First, for self-weight beam, we use base is 0.225 multiply height 0.50 times 25 for unit weight of reinforced concrete. We get 2.81 kilonewton per meter. Then we get permanent load excluding self-weight is 2.00 kilonewton per meter, and the characteristic permanent action GK is 4.81 kilonewton per meter, and for characteristic variable action QK is 3.75 kilonewton per meter. We calculate load cases, moment of inertia, stiffness, and distribution factor. For load cases, there are W1 and W2. For maximum, 12.12 kilonewton per meter, and minimum is load cases is 6.49 kilonewton per meter. For our moment of inertia is 2.34 times 10 power of 9 millimeter power 4. For stiffness, meanwhile, for K122 is 4.39 times 10 power 5 millimeter power 3. For K223 is 2.93 times 10 power 5 millimeter power 3. And for the distribution factor for joint 1 is 1.00. For joint 2, factor 2 to 1 is 0.60, and factor 2 to 3 is 0.40, and joint 3 is 1.00. Case 1, all span loaded with maximum load according to the diagram. Next, we calculate a fixed end moment for moment 1 to 2, and moment 2 to 1 is 16.16 kilonewton meter, while for moment 2 to 3 and moment 3 to 2 is 36.36 kilonewton meter. For the moment distribution based on the calculation result that have been shown on the slide, we get the sum at factor 0.60 is 39.58, and at factor 0.40 is negative 39.58. Height is the shear force at W1 for V1 to 2 is 14.35 kilonewton, and for V2 to 1 is 34.13 kilonewton. Next, on W2 for V2 to 3 is 42.96 kilonewton, and for V3 to 2 is 29.76 kilonewton. For case 2 is maximum 1.35 GK plus 1.5 QK, minimum 1.35 GK according to the diagram. Next, we calculate a fixed end moment. For moment 1 to 2 and moment 2 to 1 is 16.16 kilonewton meter, while for moment 2 to 3 and moment 3 to 2 is 19.47 kilonewton meter. For the moment distribution based on the calculation result that have been shown on the slide, we get the sum at factor 0.60 is 22.70, and at factor 0.40 is negative 22.70. Next is the shear force at W1. For V1 to 2 is 18.57 kilonewton, and for V221 is 29.91 kilonewton. Next, on W2 for V223 is 23.25 kilonewton, and for V322 is 15.69 kilonewton. For case 3 is minimum 1.35 GK and maximum 1.35 GK plus 1.5 QK according to the diagram. Next, we calculate a fixed end moment for moment 1 to 2 and moment 2 to 1 is 8.65 kilonewton meter, while for moment 2 to 3 and moment 3 to 2 is 36.36 kilonewton meter. For the moment distribution based on the calculation result that have been shown on the slide, we get the sum at factor 0.60 is 37.87 and at factor 0.40 is negative 37.87. Next is the shear force at W1 for V122 is 3.51 kilonewton and for V221 is 22.45 kilonewton. Next, on W2 for V223 is 42.67 kilonewton and for V322 is 30.05 kilonewton. For the beam analysis for the various load cases to get the most adverse conditions at any section along the beam, the shear force and bending moment diagram are drawn for these cases and the maximum shear and moment envelope are constructed. Materials for slab model that we use to create the slab is first, diverse to replace polystyrene concrete. Second, wooden skewers for reinforcement that can be visible. Fine for the reinforcement that is not visible and thick-ted to the tie reinforcement. Next, we use one ratio scale of 2 mm units to maximize the size of the model. Based on the slab picture above, show Ly is 500 mm and Lx is 400 mm. In addition, the picture above show the condition of the ties and reinforcement. Slide show the distance of each reinforcement according to the result of slab design calculation and scale 1:2, and we use top H10 to 300 and bottom H10 to 250. For long span top, the distance is 157 mm and short span top is also 157 mm. For reinforcement at the bottom for long span is 131 mm and short span bottom is also 131 mm.
Ini adalah kerangka model beam bagi elastic analysis untuk continuous beam. Alat-alat yang saya gunakan untuk menghasilkan kerangka model ini, saya gunakan cardboard, dawai besi, dan juga super glue. Dan bagi size beam pula, kita boleh rujuk dekat elastic analysis yang sudah dibentang oleh Nur Izzatul Afifi. Dengan ini, saya berharap di masa akan datang saya akan mempelajari kesilapan saya serta memperbaiki kerangka model beam ini.
Analisis trigonometri 07 GKE 18 F2008. Di dalam penghasilan projek reinforced concrete design ini, saya mengambil bahagian dalam pengiraan beam, yaitu Design of Continuous Flange Section. Akan menerangkan 9 bahagian untuk mendapatkan nilai beam flange section. Yang pertama yaitu specification, kedua effective flange width, ketiga action on slab, keempat analysis, nomor 5 main reinforcement, shear reinforcement, link arrangement, deflection, dan part yang ke-9 yaitu cracking, dan juga detailing untuk part ke-10.
Di dalam slide ini adalah merupakan hasil pengiraan saya untuk beam design of continuous beam flange section di ground floor, dan lokasi dia adalah di 1A hingga D. Dan untuk material kami, untuk unit weight of concrete kami menggunakan 25 kN meters cube. Characteristic strength of concrete kami, FCK, kami menggunakan 35 Nm square. Characteristic strength of steel, FYK, kami menggunakan 500 Nm square. Characteristic strength of link kami, FYK, kami juga menggunakan 500 Nm square. Untuk nominal concrete cover kami menggunakan 30 mm dan kami assume diameter bar 1 kami 20 mm, diameter bar 2 kami 16 mm, diameter link kami 6 mm, dan ini adalah untuk desain beam 1A hingga D. Di sini adalah data-data yang telah diberikan oleh lecturer kami untuk mendapatkan permanent load, variable load, karakteristik strength of concrete, dan juga karakteristik strength of steel. Untuk kumpulan kami, kumpulan 11, GK kami adalah 2.00, QK kami adalah 3.75, FCK kami 35, dan FYK kami adalah 500. Untuk flange width kami adalah BW 225 mm, HF 110 mm, H 500 mm, B kami adalah 2388 mm, dan actual flange width kami hasil tambah B1 dan tambah BW adalah 2613 mm, dan span A, B, dan juga CD kami adalah berjumlah 1128 mm. Untuk span BC kami adalah 1053 mm, dan action on slab kami bagi GK adalah 4.75 kN/m², dan karakteristik untuk GK kami adalah 3.75 kN/m², dan ini adalah action on slab kami.
Di dalam slide ini adalah hasil pengiraan main reinforcement kami untuk span A, B, dan C, D. Di dalam slide ini adalah langkah-langkah untuk mengira shear reinforcement, dan ini adalah hasil pengiraan saya untuk beam continuous flange section. Ini adalah untuk pengiraan link arrangement, dan ini adalah juga langkah-langkah saya di mana saya mendapat link arrangement kami. Untuk X1 kami adalah bernilai 1.88 meter, X2 kami bernilai 2.64 meter, dan juga X3 kami bernilai 2.38 meter. Dan untuk minimum transverse steel area kami, yaitu kami mendapat 187 mm² per meter, yaitu deflection dan cracking dan juga detailing. Dan untuk deflection kami pula, kami mendapati actual span effective depth kami adalah allowable, dan itu adalah oke, selamat untuk digunakan. Dan juga cracking kami bagi bar spacing kami juga adalah oke, di mana nilai dia adalah rendah, seperti nilai yang telah ditetapkan.
Ini adalah kerangka model beam bagi beam ground floor untuk continuous beam. Alat-alat yang saya pakai untuk menghasilkan kerangka model ini adalah 8 batang chopstick, wire yang tidak lagi digunakan untuk mengambil isi tembaga di dalam wire itu, dawai besi halus, dan juga span berukuran 3 cm x 6 cm. Dan bagi size beam pula, H adalah 195 mm, HF 200 mm, BW adalah 20 mm, spacing bar 6.5 mm. Namun untuk kerangka model saya hanya ikut size panjang kayu chopstick, dan diharap di masa akan datang saya dapat memperbaiki kesilapan saya dari segi membuat model beam ini.
This is the layout of shear force coefficient for ground floor to all slab panel. For panel AD or 1, 2, Ly over Lx 5000 over 4000 is 1.25. So this is 2-way slab. And for the panel A to C or 2, 3 is Ly Lx 6000 over 5000 is 1.2, also 2-way slab. And for the panel CD or 2, 3 is 5000 over 3000 is 1.67, also the 2-way slab.
While for the layout of bending moment coefficient, is stated here that there is 3 case 4 that was used, which is the 2 adjacent edges discontinuous, while there was 2 case 3, which is 1 edge discontinuous, and there is 1 case 2 for 1 short edge discontinuous, as stated in this slide.
Bagian ini pula saya akan menerangkan tentang pengiraan step untuk slab, yaitu slab design. Dan ini adalah slab design di mana yang akan saya terangkan. Lokasi dia adalah 1 hingga 2, A hingga B, dan ini adalah first floor. Di dalam slide ini juga saya akan menerangkan 4 bahagian, yaitu specification, yang kedua adalah slab thickness dan durability, fire and bond requirement, dan ketiga adalah action, analysis, dan main reinforcement, dan yang terakhir adalah shear force, deflection, cracking, dan juga detailing. Di dalam slide ini adalah specification bagi slab design di panel 1, first floor, dan apa yang kami dapat untuk long span kami LY adalah 5000 mm dan short span kami LX adalah 4000 mm, dan ianya adalah two-way slab di mana ia adalah kurang daripada 2.0, dan karakteristik action kami bagi permanent GK adalah 2.0 kN per meter, variable kami QK adalah 3.75 kN per meter, design life kami adalah 50 years, fire resistance kami adalah R60, dan exposure class kami adalah XC1, dan material yang kami gunakan untuk konkrit kami yaitu FCK adalah 35 N per mm square. Untuk strength of steel kami FYK 500 Newton per mm square, dan unit weight of reinforcement concrete kami adalah 25 kN per cube, dan kami assume diameter bar kami untuk slab design kami adalah 10 mm, dan di sebelah kanan slide ini pula adalah pengiraan untuk slab thickness dan durability, fire dan bond requirement kami. Di dalam slide ini pula adalah pengiraan untuk action, analysis, dan juga main reinforcement, dan ini adalah pengiraan yang telah kami buat. Di dalam slide ini pula adalah untuk shear force, deflection, dan juga cracking, di mana deflection kami juga adalah OK dan ia selamat untuk digunakan pakai, dan cracking kami juga, square spacing kami juga adalah OK, di mana ia juga selamat digunakan pakai. Dan untuk part terakhir adalah detailing. Ini adalah contoh lakaran detailing kami untuk slab design kami.
Greetings to Sir Dalman, our reinforcement concrete and design lecturer. My name is Dodi Preslimiki and my metric number is 07DKA18F2005. Today, I will be going to present the calculation for bending moment and axial load for column. Other than that, I will also talk about the design of our column. As you can see here, the calculation for column will be taken at ground floor column of A1. So, we start our calculation by calculating beam self-weight at the calculation that we obtain is 2.81 kN per meter. So, the loads on beam for first floor and ground floor were shown in this picture. So, in order to calculate the distribution of load from slab to beam are as followed by from panel A12 and our shear coefficient is 0.33, and for panel 1AB our shear coefficient, which is our BV, is 0.33, and the characteristic of permanent load on beam A12 is our GK 8.46 kN per meter, while for our characteristic of variable load A12 we obtain our QK is 4.95 kN, and the total design load on beam A12 is 18.85 kN per meter. And for our characteristic for permanent load on 1AB is shown here that our GK is 10.03 kN per meter, while for our characteristic of variable load 1AB, which is our QK, is 6.19 kN per meter, and the total design load on this beam for 1AB is 22.83 kN per meter. And as you can see here on this part of this slide, the beam at roof, we have calculated our shear force for each of the beam that was about to calculate it in order to find the NED on each of the force that was being distributed from each beam and also from the slab. So beam at roof, which is our A12, which is our shear force is 5.62 kN, and for our beam at roof for 1AB, which is our shear force is 7.03 kN, and for beam at first floor, as you can see here, beam for A12, the shear force is 37.7 kN per meter, and for our beam at 1AB, the shear force is 57.08 kN, and therefore our total NED is 133.81 kN by adding up all the shear force of the beam and also calculating the column self-weight, and we obtain our NED, which is 133.81 kN. So, for bending moment on ZZ, we start our calculation by calculating the stiffness for column and also for beam. So after that, we start to calculate for fixed end moment, which is our delta M is 47.56 kN per meter for first floor in this below the column. And for the moment in column, as you can see here in this slide, our moment in column is 24.52 kN per meter, while for the moment in upper column, we have obtained our amount of calculation, which is 10.32 kN per meter, and for the moment in lower column, as you can see here, 27.52 kN per meter. And for our specification, the classification of this column is a braced non-slender column, and the material that we have been used here is our concrete is 35 Newton per millimeter square, and for our reinforcement for FYK is 500 Newton per millimeter square, and the exposure class is XC1, and for our fire resistance is 1 hours. Therefore, the design life is 50 years, and the size of our column is 280 times by 350 mm, and the effective length, which is our LO, is 4 meter, and we assume that our link is 6 mm, and for our rebar is 20 mm. So for the durability, bond and fire resistant, as it was stated here, the minimum cover with regard to bond for C minimum of the cover, which is 20 mm, and for minimum cover with regard to durability, our C durability is 15 mm. While for our minimum required access distance for R60, the resistance of AOSD for our 36 mm. While for minimum cover with regard to fire, which is our C minimum, is 20 mm, and allowance in design for deviation, delta C def is 10 mm. While for our nominal cover, as you can see here, our C norm is 30 mm, and the design moment for non-slender column, the design moment, which is our MED that we have gotten here, is 25.86 kN per meter. And for our reinforcement here, as it was stated here, for our D2, we have to divide by H in order to get our amount here, which is 46 divided by 350, which is equals to 0.13. And since the minimum of the column of the design chart does not intersect, therefore our AS minimum was used as column reinforcement. So as you can see here, it was stated here that our AS min here is 314 mm square, which is we will be going to use 4 bars, which the bars is 10 mm in diameter, and the AS max is 3920 mm square, where our links minimum is 0.280 times by 10, which is 2.8 mm or 6 mm. While for our SV max, the lesser of 20 times 10 equals to 200, H4 to 200. At section 300 mm below and above beam and the lappet joints, SV max 0.6 times by 200 equals to 120 mm. So we use H4 to 120 mm for distance of each of the links. Materials for reinforcement column. So the first materials that we have been used for this design of our model in this column, the first one is our steel string, and for the second one is our fishing string. As it was stated here, the reinforcement bar and also the links and also the tie was stated in this picture. Therefore, our C norm is 30 mm, and the angle for the links that was used to lock in order to make sure that the links won't separated from each other is 135 degree.
Hai, nama saya Marlene Melanie Masilo Simon dan kat metrik saya ialah 07 DKL 18F 2039. Di dalam penghasilan projek reinforced concrete design, saya mengambil alih bahagian column slenderness dan juga non-slenderness. Okey, ini yang saya akan membentang iaitu specification, effective length of column, radius of duration, slenderness ratio dan juga effective length of column. Okey, kalau kita lihat di sini, ini ialah specification di mana kita tahu dimension dan juga size dia. Column dia kami dapat 3.500 dan main beam dia kami dapat 5.000. Bagian moment of inertia, kolom LZ dia kami dapat 0.10 dan LY dia kami dapat 0.64. Bagi main beam dia kami dapat 2.34 dan juga stiffness dia bagi kolom Z kami dapat 2.86. Main beam dia 4.7 dan juga KMB2 dia kami dapat 4.7 sama juga. Okey, bagi relative column stiffness Z yang sama dengan X, top end dia kami dapat 5.7 iaitu lebih daripada 0.1. Bot end dia pun sama, lebih daripada 0.1 iaitu 5.7. Kalau Y kami dapat top end dia 4.3 lebih daripada 0.1, bot end dia pun sama juga 4.3 lebih daripada 0.1. Okey, ini ialah bagi effective length of column, radius of duration dan juga slenderness ratio. So bagi effective length of column, nilai yang kami dapat bagi IOX, which mean IOZ sama saja, iaitu 3.444 mm, dan bagi IOY kami dapat 3.348, dan bagi radius of duration IZ dia kami dapat 31.94 mm dan juga IY dia kami dapat 80.8 mm. Bagi slenderness ratio Z dia kami dapat 107.8 dan juga Y dia kami dapat 41.4. Okey, dan ini bagi slenderness limit. Yang ini semua kiraan dia saya rujuk daripada buku. Dan di sini kamu boleh lihat pengiraan dia. Okey, kita balik lagi bagian effective length of column using simplified method vector darab clear height. So Z dia kami dapat 2625 dan Y dia kami dapat 2700. So kalau bagi X, beam at both side, beam dia lebih besar daripada kolom, dan Y dia pun sama juga, beam lebih besar daripada kolom. So bagi tempat slenderness ratio, Z dia kami dapat 0.762 iaitu kurang daripada 30.98. Dan juga Y kami dapat nilai dia 0.806 iaitu kurang daripada 36.67. So Z dia column is non-slender about Z, and bagian Y pula column is slender about Y. Yeah, thank you, that's all.